Okay, going over question one in problem set two, parts A, B, and C ask us to look at two ruthenium metal complexes and find the total electron count of the metals, oxidation state of the metals, and D, electrons of the metals. So if we look at complex A, let's jump right into the ligands. We have a 6-carbon aromatic ligand with some substituents, but that'll donate 6 electrons. We have an aromatic oxygen or an aryl oxygen ligand that'll donate 2 electrons and have a negative charge, -1 charge. And then we have our alkene ligand that's going to have a -1 charge and donate 2 electrons in this bond. And so as a result, we have 2 overall negative charges. So we're going to have a ruthenium 2 plus ligand. And so ruthenium 2 plus is going to have 6 d electrons. So in filling this out, we have added all up a 16 electron complex with ruthenium 2 plus and 6 d electrons. For the second complex, we have a metallocyclopropene ring that's formed as a result of the isomerization of the first complex. So very similarly, we have our first and second ligand, same as last time, donating 6 electrons and 2 electrons. And then this new sort of bidentate ligand that's formed is going to have a overall -3 charge and be donating 6 electrons, so 2, 4, 6. And then overall, we have 4 negative charges, so we're going to have a ruthenium charge of 4 plus, and ruthenium 4 plus has 4 d electrons. So if we add it all up, 6 plus 2 plus 6 plus 4 is going to be an 18 electron complex with ruthenium 4 plus and 4 d electrons. Now moving on to part D, we have 2 rhodium complexes, and we're asked to determine which is more likely to isomerize into a similar cyclopropane ring that we saw, cyclopropene ring we saw in the first one. So this first rhodium complex is a rhodium 3 rhodium 3 plus with 16 electrons total. And the second complex, complex D, is a rhodium 3 plus with 18 electrons total. So if we look at the conformations, the first rhodium complex is going to have, let's look at the ligands. So the silicon ligand is going to have a negative charge and donate 2 electrons. The cyclopentadienyl ligand is going to have a negative charge, donate 6 electrons. And this now bidentate ligand is going to have a -3 charge, similar to in the first part, and donate 6 electrons. So overall, we have a rhodium 5 plus ligand, center, metal center, and that's going to have 4 d electrons, leading us to overall having an 18 electron complex. Whereas in the second one, we see that you're going to have 4 ligands from the phosphates, 6 from the cyclopentadienyl, and 6 from the bidentate carbon ligand. And so you also have a rhodium 5 with 4 electrons, but what that leads us to is what would theoretically be a 20 electron complex. And so if we look at these two, comparing which would be most likely to isomerize, a 16 to 18 is far more favorable than the highly unlikely 18 to 20. So this complex would exhibit more fast isomerization. Thank you.